Hi, in this lesson I want us to look at how likely eruptions are, and if we can use one measure of probability to assess the risks that volcanoes of different sizes actually pose. For this lesson you need a calculator, and you also need the 20th century eruptions datasheet. You'll find this stapled to your Theme 0 Part 2 booklet. We're working on pages 4 and 5 of that booklet. Let's go. If we're going to look at volcanoes and the risks they pose, we need to have some way of measuring how big they are. I'm not talking here in terms of area, but in terms of the material that's actually erupted by a volcanic eruption. It's a measure that we call the Volcanic Explosivity Index, or VEI. Now, VEI will use a number of different terms to describe the 9-point scale that we use for VEI. Those words are listed in your booklet. Can you put those in order from the smallest eruption that we call effusive, which is a level 0, right the way up to an eruption of VEI 8? Remember, these words are trying to describe ever more large eruptions. Have a quick go at that. See if you can put them in order. Okay, let's have a look at these. 1 can be described as gentle, VEI2 explosive, 3 is catastrophic, 4 is cataclysmic, 7 is supercolossal, and 8 is described as megacolossal. Now those words are handy, but as geologists we really need to measure how big they are. And the thing that distinguishes these different levels on the VEI scale is the volume of material, so that's ash or lava, that's actually erupted from the volcano. And this is measured in cubic kilometres. Now, on your table on page 4, I've already completed some of the lower values for this. Because when we start going above VEI2, each point on the scale is 10 times bigger than the one before it. So for example, if VEI2 is 0.001, VEI3 is going to be 10 times that. So it'll be 0.01. Can you fill in the rest of that column? Remember, multiplying by 10 every time. Use a calculator if that helps. Once you've done that, can you then convert those values into standard form, into powers of 10? Count the zeros, and a bit of a tip, start from the top and work down. You might want to watch the video that's linked in the email. So press pause now and have a go at questions 2A and 2B. See what you can come up with. Okay, let's see what the results are. So remember, we're multiplying by 10 every time. So 3 is going to be 0.01, 4 will be 0.1, 5 is 1. See how the numbers are moving relative to the decimal place every time. VEI6 erupts 10 cubic kilometres, VEI7 100 cubic kilometres, a VEI8 1000 cubic kilometres. If we convert that into standard form, remember we need to count the zeros. And then when we get to numbers that are less than 1, we need to start using negative powers. Each of these values, remember, is a minimum for that level. Okay, now we've got that information, let's have a look at some eruptions from history. This is a graphic that tries to show the relative scale of some of these different eruptions. It also gives the amount of erupted material. What I'd like you to do first is to work out where on the VEI scale each of these eruptions is. Write next to the name of each of these what you think the VEI for that eruption is. Once we've done that, I want you to consider how likely these eruptions are to happen. What I've given you here is some of the data for the 20th century. So from 1901 all the way through to 2000. Each of these eruptions has been counted. On your worksheet, I've given you a list of all the eruptions of VEI 6, 5 and 4. What I'd like you to do, first of all, is count up the number of eruptions at each of these VEI levels. Once you have that, I'd like you to work out something we call the return period. What's the average length of time in between eruptions of each of these different VEI levels? So can we divide the number of eruptions by 100 years? So can we divide 100 years by the number of eruptions for each level? So we know roughly how often each of these are likely to occur. Can you then identify a pattern? And why do we not have any VEI 7 or 8 eruptions registered in the 20th century? Can we work out the chances of those erupting? So press pause now and have a go at questions C, D and E in your booklets. Okay then, let's have a look at some results. This is the relative size of some of these different eruptions. And these are the VEI figures for each of them. I hope you managed to get all of those. So, if we look at the chances of these occurring, if we count up the eruptions from the 20th century, we should get figures that look like this. There were 52 VEI 4 eruptions, 9 VEI 5 eruptions, and 3 VEI 6 eruptions through the 20th century. Gives us a total of nearly 6,300 eruptions in total, but most of those are VEI 1. If we look at the chance of these occurring then, by calculating this return period, we get figures similar to this. So VI1 occurs roughly every week or so, maybe just over a week. VI2, there's about one every month. VI3, one every 5.2 months. VI4 is about every 2 years. VI5 about every 11 years. VI6 every 33 years. And no values for 7 or 8. But does that mean that 7 or 8 aren't going to happen? I don't think so. There's a distinct pattern here. The bigger the eruption, the less frequently it happens, the less likely it is to occur. But when it does happen, the bigger it is, the more destructive it's going to be. There are no VI7 or 8s because they don't happen not often enough. 100 years just simply isn't enough time to be able to catch a VI7 or 8 eruption. The time periods between them may be measured in hundreds of thousands of years, particularly for VI8. But those are the ones that have the greatest potential for destruction. Okay then, so we can see that the size of an eruption and the risk it poses are interlinked. Next time, we're going to have a look at earthquakes and see if we can look at the techniques we use to locate the epicenter of one particular earthquake from its effects. I'll see you then.